Welcome to a lesson with Dr. Powell. Let's take a look at an alternative to the quadratic formula and the regular version of completing the square. When we're looking at a quadratic, we like to solve an equation like this, where we have a quadratic polynomial set equal to 0. We want to know what values of x satisfy this equation. All right, let's get started. This is a synthetic division alternative. So we take the coefficients, 3, 12, -11, make a little synthetic division diagram. All right, drop the 3. Now what we're going to do is we're going to figure out what goes here, here, and even we're going to make another little box here in order to figure out what x is equal to. We drop the 3. We don't know what goes here if you're familiar with synthetic division, and this guy will seem bizarre because that's not usually there, but we're putting it there. We'll see its use in a minute. So we're going to drop the 3. We don't know how to get here. However, what we're going to do is we're going to take this 12 and just half it, and it comes down here to be 6. Now we're ready to figure out what goes here. What we do is we take this number, divide by that number, and change the sign. 6 divided by 3 is 2. Change the sign to -2. Okay, now how do we get this? Well, we use this -2 and continue on from the 6. Notice we didn't have something here, but that's okay. We could backtrack and figure out what it is, but we don't need to. We say -2 times 6. We put the result here is -12, and then we add. We're going to get -23. All right. Okay, so then what we do is we take this -23, just like we said 6 divided by 3 and change the sign, we're going to say -23 divided by 3 and change the sign. So we're going to end up getting 23 thirds. All right, so what is x equal to? -2 plus or minus the square root of 23 thirds. And the nice thing about this is that we're not trying to simplify the quadratic formula and group it in different places. Many people like to maybe rewrite a square root of a fraction so you don't have anything in the denominator that's in a square root sign. However, this is good enough for our purposes for this particular example. All right, now completing the square also comes out. What if we wanted to just look at this and rewrite it as a square chunk plus a number? Well, it's all right here. If you think about this right here as being like 3x plus 6, just imagine factoring out that 3. You'd have 3x plus 2. By the way, is the same thing as thinking I'm dividing by x plus 2 as synthetic division, right? It's that same guy. And we just throw a square root on it, put a -23, and we are done. It comes all from that diagram. So we can use a synthetic division diagram like this to quickly get the roots of a quadratic polynomial, as well as getting the completed square form. Notice that as in this particular instance, what we're doing is we're basically saying, okay, the reason why we took half of this like this um, actually amounts to the fact that we want this guy, the quotient, to be this number times what we're getting over here. You can check it out, but that's essentially what's happening. Now that automatically makes a square, and then whatever's left over is just a constant. So it really just pans out nicely. And then this thing right here really comes from the idea of how we're completing the square. I mean, notice, just kind of stick this in to this part right here. Notice the -2 will cancel with that 2, and you're squaring, so plus minus goes away. And then you're just left with 23 over 3, and 3 cancel. It makes 0. So it turns out just fine. Really, the synthetic division process works well for finding out for completing the square. And then this is just an extra little tidbit that we get from it as well. Thanks for watching.